So, in chapter 10.3, this is our last chapter of this section that we're going to look at, and it's on compound interest. So, what you will learn in this section is how to compute compound interest and how to calculate present value. So, an investment is the use of money or capital for income or profit. Investments include stocks, bonds, CDs, a bank savings account. Those are investments. And in a fixed investment, the amount invested as principal is guaranteed and the interest is computed at a fixed rate. Like, for example, your savings account, or for a CD, for example, is at a fixed investment amount. In a variable investment, neither the principal nor the interest is guaranteed. These include things like a bond, sometimes mutual funds, money market accounts sometimes are variable investment accounts. So, compound interest that is computed on the principal and any accumulated interest, is called compound interest. In compound interest, typically there is an annualized rate of interest that is provided to the investment on a certain period, like a monthly period or a quarterly period or a semi-annual period of time. So here's the formula. It looks like an exponential, and it is. It's A is equal to P the principal times 1 plus R divided by N raised to the NT power. So if T is variable or if N is variable, you can see it's kind of like an exponential situation. So A is the amount that is accumulated in the account after a certain time period. P is the principal, which is the initial investment. R is the annual interest rate as a decimal, so you always put interest rates that are in percentages into decimals to work with them. T is the time in years, and N is the number of compound periods per year. The compound periods that we're going to either work with is N is either going to be equal to 12, which is for 12 months, or N is equal to 4 for a quarterly period of time. If it's quarterly compounded quarterly, N will be 4. And those are usually the two that you would probably be working with in this chapter. So our example problem is the following. Kathy Mowers invests $3,000 in a savings account with an interest rate of 1.8% compounded monthly. If Kathy makes no other deposits into this account, determine the amount in the savings account after 2 years. So, in this case, our solution is we have P is equal to 3,000. R, when we put it in decimal form, is 0.018. N is 12 because it's compounded monthly, and T is 2. So we plug all this thing into our formula, And we get A, the amount for 2 years, is equal to $3,000. That's our principal. Times 1 plus 0.018 divided by 12, parentheses, raised to the 12 times 2, that's 12 times 2, power. So when you put this in the calculator, what you will do first, typically, is you would do the 0.018 first, and you divide it by 12. So that's what you would do in the calculator first. Then you would add 1. And then once you have that result, then you would take 1 plus that result, the new result that you got, right? And then you would raise it by using the caret symbol times 24. And you say, well, why by 24? Well, 12 times 2 is 24. Once you have that result, then you multiply it by the 3,000. So we'll go through the steps again. When we did the actual division of 12 into 0.18, we got 0.0015. You do not want to round at all during this process. You add 1, right? And so that would be our next step. And now we raise it to the 24th power, the 1 times the 24th power. So when we did that in our calculators, we got 1.0366279. Again, don't round yet, right? Now multiply it by 3,000, and you get this result. Now you can round to 2 decimal places. Why? Because we're in the cents. So the amount in the account after 2 years would be about $3,109.88. So essentially, she accumulated $109.88 in the compounding of interest. So the effective annual yield, or annual percentage yield, is the simple interest rate that gives the same amount of interest as the compound rate over the same period of time. So from the last problem, we can find the annual percentage yield rate in the following fashion. We found out that the interest rate last time from the last problem was $109.88, and that equaled essentially the principal, which was $3,000, times the rate times 2 years, right? Now, when we actually end up doing the problem and we're trying to find the actual effective annual rate, the APR, we divide 109.88 divided by 6,000, right? 6,000 is because we actually ended up 2 times 3,000 is equal to R, and R in this case is equal to 0.0183, it turns out, right? Rounded to 4 decimal places. So we got a little bit better interest rate by the compounding factor. Now we'll look at the present value formula. This formula comes from the same formula. We just divided both sides of the equation by 1 plus r over n raised to the nt. By the way, this should have a division symbol. So P is the present value or principal to invest. A is the amount to be accumulated in the account. R is the annual interest rate as a decimal. N is the number of compounded periods per year. And T is the time in years. So suppose I want to know how much to invest now to get a certain amount of money in the future that I can utilize to either buy a house, to buy a car, to invest in one of my child's educations. I would use this present value formula. So here's our example for college savings. Will Hunting would like his daughter to attend college in 6 years when she finishes high school. Will would like to invest enough money in a certificate of deposit CD now to pay for his daughter's college expenses. If Will estimates that he will need $30,000 in 6 years, how much should he invest in a CD that has a rate of 2.5 compounded quarterly? Well, in this particular case, remember A is equal to 30,000. So in our present value formula, we put A is 30,000. On the bottom, because it's 2.5% and it's compounded quarterly, or maybe it's monthly actually, we get the following denominator, 1 plus the denominator, and for actually for 6 years, I guess it's compounded quarterly. For 6 years, we raise it to the 24th power. So when we get 30 divided by 1.1612320, he needs to invest approximately $25,833 initially to have approximately $30,000 in 6 years. So the formula works basically the same. This part of the formula, again, is, right, we have A divided by 1 plus R over N raised to the NT power, right? And that's equal to the principal that we will need. So in this chapter, in summary, we learned to calculate the amount of money after T years and our interest compounded over a period. We learned to calculate the amount of money needed to invest at T years in our interest compounded over a period to calculate the money we need to invest in. So this concludes our chapter 10 on money and financial mathematics, and we should be ready for our next exam.